Miss, you're muted.
Thank you. Oops, I
You're
forgot.
welcome.
I never mute myself, so I forgot. Okay, so these rules for translation, what sets them apart from other types of rules is that you're always going to be adding or subtracting a number from the X or from the Y. So whenever you see a problem and you see that it's adding or subtracting, that's how you can tell that it's going to be a translation. So what we're going to do today is we are going to not only be able to see a figure and then translate it, but you also have to see a translation and figure out what was the rule behind it. So let's go ahead and write down one more definition, I believe. Yeah, it's just one more. So let me tell you what to write down. They kind of write it a little confusingly, so I'm actually going to rewrite this definition for us. Hold on. So vector notation is a simplified way to write a translation rule. So vector notation is a simplified way to write a translation rule. And here's an example. So when the parentheses are kind of like little, instead of being curves, they have an angle. So notice these parentheses are a little bit different. That's how you can tell that it's vector notation. So for example, here, when I have those little brackets and the brackets say 5, 3, this means 5 units up, or 5 units to the right, my bad. And 3 units up. And if it was a negative number, then it would be left and down. But since it's positive, that means it's right and up. Guys, let me see your faces. Let me turn your cameras on. I only see Daniel and Emily.
I'm sorry. I didn't know my camera was off. I just rejoined.
Thank you. No worries. Yes, Tyrone. And like I said, you don't even need to show me your face. Look at Janelle's, Emily. I don't see their faces, but just keep your camera on so that I know you're there. Okay. Any questions on vector notation? All right. So you don't have to write this part down, but I just want you to see on the graph, vector notation is kind of like if I start at P and I end at Q. So if I'm going from P to Q, it follows that line that they draw, right? So this is my line that moves P to Q. That line is my vector. So that's why it's called vector notation, because the line that connects them, that's what we call a vector. And as you can see, it's showing you how the vector goes 5 units to the right. So that's where the 5 comes from. And then it goes 3 units up. So it's kind of like something that we've seen before. What have we seen that looks like this in algebra? When you have a line on a graph and you're seeing how far to the right, like if you're looking at the...
Is it like rise over run, something like that?
Yeah, exactly. It's very similar to rise over run. It's kind of like slope. So vector notation is just kind of like a way to do the same thing, but this time we're talking about it kind of like with slope. So does anybody have any questions so far? Okay. All right. So let's go ahead and look at a problem. So vector notation, like I said, will always tell you how much to the left or right and then up and down. So it's like X comma Y. So by the way, with these problems, here's what's going to happen, because obviously you guys don't have the textbook in front of you, so you can't do it on a paper, and I'm not asking you to write all of this down, and I'm not asking you to graph anything right now. What I'm asking you to do is watch, pay attention to what I'm doing and watch, because at the end of class, I'm going to be sending you guys an assignment that you can do on your laptops. So at the end, you'll be able to do this on your own using technology. But for now, you kind of have to just watch and make sure you understand, okay? All right, so I have a pre-image, and I'm going to translate it using the vector -2, 3. So what does the vector tell me to do? In using words, what is this telling me to do? Hmm? I'll wait.
Is do you mean like which way it goes on the
Yeah.
graph?
Yeah, where am I going?
So would it be 2 units down and or well 2 units maybe to the left,
Okay, so what?
3 down?
Okay, so so we know it's going to be up, down, left, or right, right? Let me go back to what we just wrote down. We just wrote this down. In this example, my vector was 5, 3, and that meant 5 units to the right and 3 units up. So here, now I have -2, 3. So what is that going to be?
Wait, are we like subtracting like the pre-image coordinates or input? And what's that word I'm looking for? Plug in?
You will,
That the
but
word?
right now, I'm not asking that. Right now, I'm just asking you to tell me using words what's going to happen. So Janelli started us off. She said 2 units down or maybe to the left. So what do you guys think? Is it going to be 2 units down or is it going to be 2 units to the left?
To the left. To the left.
To the left.
Good.
The left.
2 units to the left and then 3 units
To the right.
Up.
Wait.
Up.
up. Good.
Up.
Go back to what literally we just wrote this down. This one tells you about your x, the other one tells you about your y. So that's how we know this is 2 units to the left and then 3 units up. All right, we can make a prediction which quadrant it's going to be in. So before I even do anything, I'm going to draw my pre-image just based on what they're telling me. The coordinates are 3, 0, 2, -2, and 4, -2. So there's my pre-image. And when I do my transformation, what quadrant is it going to end up in? And as a review, this is 1, 2, 3, and 4. Which quadrant am I going to end up in?
Quadrant 4.
Quadrant 4, maybe? Okay, anybody else have a prediction?
I think quadrant 1.
Quadrant 1, maybe?
Yes.
Okay, anyone else?
Or yeah, I think quadrant 1.
Okay, so either 4 or 1. Let's find out. So now I'm going to move my image 2 units to the left and 3 units up. I'm going to use the coordinate plane, or sorry, the coordinate points first. So like Jalen was saying before, the image, what am I going to do to the x? I'm going to subtract 2. And then to the y, I'm going to add 3. That's just from my vector notation. So now I can plug in all those numbers. So 3 minus 2 gives me 1, and 0 plus 3 gives me 3. What do I write for the second point? Eric, what should I write for my second point? take what I start, I have 2 comma negative 2. What happens when you do the math? I'm waiting on Eric. If you don't know, say you don't know.
0, comma 1.
0, comma 1. Very good. Emily, what am I going to get for the third point?
2, comma 1.
2, comma 1. Good job. All right, now I go ahead and I'm going to plot those points. So I have 1, comma 3, 0, comma 1, and 2, comma 1. Whose prediction was correct? Where did I end up? Which quadrant?
1.
1.
We ended up in quadrant 1. Any questions so far? I'm going to just be calling names from now on. It's going to move us way faster. Okay. Next problem. Again, you do not need to write this down, so I should see eyes on the screen because there's nothing to write down yet. You're just watching. Now I'm going to do the same thing. Who can explain with me using words what's going to happen when I apply my transformation?
It's going to go 4 units to the left and 1 unit up.
Good. Now, what I want to do with this, I'm going to, first, this is vector notation, right? -4, comma 1. But now I want to write it using a math rule. This is the other way that we know how to do it from the beginning, from the bell ringer. We start off with x comma y, draw an arrow, and then just like the vector notation, you're using that -4 and that 1, but you're splitting it up. So now it's x minus 4, comma y plus 1. It's just 2 ways to write the same exact thing. They're both telling you the same thing. So first I'm going to plot the points of my pre-image, 2, comma 4, 1, comma 2, 4, comma 2. Okay, my, this is A, this is B, and this is C. Now, instead of doing this with the coordinate points the way that they did it before with that chart, instead of doing it with the chart, I'm going to use my eyes. I know that I need to move each point 4 units to the left and 1 unit up. So I'm just going to use my eyes to do that. I'm going to start with A. Move it 4 units to the left, 1, 2, 3, 4, and 1 unit up. What do I call this new point?
A prime.
Yeah, good job. A prime. Then I go with B, same thing, 4 units to the left, 1, 2, 3, 4, 1 unit up, B prime. And with C, 1, 2, 3, 4, and 1 unit up, C prime. Okay, that's what makes translation so easy. You do not need to do all that work of writing things down in a column because you can literally just use your eyes and move the image to where you need it to be. And just a little review, my original one, that was called the pre-image, and my final is the image. So don't forget that's what those 2 words mean, pre-image and image. Any questions so far? Okay. All right. This one is very similar, so I'm going to skip it because right now we're doing very basic problems. Okay. Now let's go ahead and make things interesting. Can I have a volunteer read for us this problem?
Me.
Go ahead.
Match each set of coordinates for a pre-image with the coordinates of its image after applying the vector 3 comma negative 8. Indicate a match by writing a letter for a pre-image on the line in front of the corresponding image.
Okay, cool. For this one, you don't necessarily need to write it down, but at least just in your head, think about where each of these is going to match to. So when you match something, you would put the letter on the line. So for example, this is not necessarily correct, but if these two were to match, then I would put A right here. So we know our vector is 3 comma negative 8. Somebody tell me in words. Matter of fact, not just somebody. Let's have Samaj. Tell me in words what this means. Samaj, you there? Okay, she might not be with us. Okay, in that case, let's have Janelle's. What does that vector tell us to do?
It tells us to do uh, 3 to the right and, or well, 3 up maybe.
Right or up? Pick one.
3 up and 8 to the left.
Okay, you have them backwards. Remember that coordinate points go x, y. X represents the x-axis, which goes to the left and the right. So the first number is left and right. In this case, it's positive, so that's 3 units to the right. You had it right the first time. Okay, so if that's right, then the other one means 8 units what?
Down.
This one's down. There you go. Okay, and when you're matching, you have to do the math. You have to see which one is, so for example, do you guys want me to do the first one together? Would that be helpful? I mean, 0 responses. Okay, I'll just do it. Okay, so for A, I have 3 points, and I'm trying to see which of the possibilities over here take those 3 points and add 3 to the x value and 8 to the y value. So for example, 1 comma 1, I would add 3 to the x, so that should be a 4, and then I have to subtract 8 from 1, so that should be negative 7. So I'm looking for 4 comma negative 7, and I see it right there. Then I'm going to check the other one. So the next point would be 10 comma 1. First, I'm going to add 3 to the 10, so that should be 13. And then I'm going to subtract 8 from the 1, so that should be negative 7. And that does match up. 13 and negative 7. Same thing to the last one. I should add 3 to the 6, which would be 9, and then subtract 8 from the 5, which should be negative 3. And that does match up. So in other words, the vector 3 comma negative 8 was applied to the points in letter A. So all 3 points were changed by adding 3 to the x value and subtracting 8 from the y value. So therefore this one matches up. Does that make a little bit more sense? Okay. All right, so now you guys try B, C, and D. Try and figure out which of the remaining options takes B and applies the vector. Takes C and applies the vector. Takes D and applies the vector. Take 4 minutes. Yeah, send us your answers and send me your answers in the chat privately. Okay, I have 2 people in the chat who got it correct. Do I have anyone else? Good, 3 people. All right. Let's go through the answers. So A was the one we already did. B goes where, Perla?
Yes.
Where does B go?
B goes with the fourth one.
Go to, sorry, I couldn't hear you. Where?
B goes with the fourth one.
The 4th one, good. The very last one at the bottom. Where does C take me, Alejandro? We can't hear you, bud. I don't know if you're unmuted, but I still can't hear you. You can put it in the chat though. One. Good, yeah. So he just put it in the chat. It goes to the top one. So that's C, which means the last one,
Goes
D,
to the second one.
goes to the second one. Does anyone have any questions on that? If you got a different answer, or you would like me to explain once again? Okay, cool. So with a lot of the times on your tests, the reason I like this question is because a lot of times on your tests, you're going to get a problem that has no diagrams, no graphs, no pictures, nothing, just words and math. And you have to be able to see it, understand it, even though you don't have a picture in front of you, you have to be able to visualize it in order to solve it. Okay, so now we're going to go through a couple of problems where we see it and we have to write the rule. We're going to write the rule using the mathematical rule, just like we've been doing before, and then we're going to write it using vector notation. Actually, you know what? Let's do 3 things. I changed my mind. We're going to first explain it using words, then math, and then vector notation. So take a look. You can get real close up to the screen and count all the lines. Make sure you're counting carefully. But let's have Daniel. You go first. You don't have to go right now. So take a look first. Take a couple seconds to look and tell me using words where we're going to get from A, B, C to A prime, B prime, C prime. So starting from the black one.
Two to the right and up 3, no, yeah, up 3 units.
Good.
Two to the right.
You got it. Nice job. Okay, so that's our words. Now I'm going to write the same thing using math. So math is the one with the arrow, okay? So we got x, we always start with x comma y, arrow. We're going to fill in those blanks over here. So for this part, I would like Jalen to go next, but you can take your time. So whenever you're ready, tell me what I should put in these blanks.
forgot I'm doing again. Can you tell me?
Mm-hmm. So I'm setting up this, I'm doing the math part right here, and I want you to fill in these blanks. So what do I write that's going to tell me to go 2 units to the right and 3 units up?
Wait, from which one? The black triangle or the red one?
Starting from the black, and you can always tell which one starts because it's the one without all of the primes. So notice how this is a prime. That's how you know that's the image, and the black one is your pre-image. So starting from black.
Yeah. I know what it is, but I can't think at the moment.
Okay, here's what I'll do. You'll be up on the next question. You'll have to do this part. But for this question, would anyone like to volunteer to explain it? Perla, go ahead.
Okay. So it would be x plus 2
Mm-hmm.
and then y also plus 2.
Y plus
Oh, 3, sorry.
3. There you go. That's all it is.
Oh, it was that easy,
It's
and my
that
brain
easy.
can't think.
It's that your brain
Wow.
hasn't been paying attention.
Well,
All
that
right.
too.
Now the last one is the vector notation, and that's the one with the special brackets that look like this. And Emily, what am I going to put in the blanks here? Is Emily there? Just checking. Or has she abandoned me?
2,3.
Yes, girl, you got it. 2,3. That's all it is. So notice, the first number in vector notation is the same as the x, and this one's the same as the y. It's just a shorter way of writing it. So just to review all of this, when you go to the right, that's your x. Okay, so that's why I have plus 2. And then this comes up over here. When you go up, that's your y. So that's why we had y plus 3, and then that 3 shows up over there. So it's literally as easy as that. You just have to follow that same pattern, and you have to recognize the difference between the math rule and the vector notation. So let's try another one. It's going to be very similar. So we're going to do words, math, which Jalen, that's going to be you, okay? So be ready. And then vector. Starting with words, let's have Tyrone. Look at the picture, take a second to count, and then tell me using your words. Tyrone, you're doing the first thing. So you're going to tell me using words how to go from the pre-image to the image.
My computer restarted once again.
You're good. At least we can hear you now.
Well, I know what it is.
Take a couple more seconds. And I want you to say it out loud, Tyrone. Don't just type it in the chat. You can't? Oh, okay, fine. Type it in the chat then. Tyron, you got 5 seconds before I give it to someone else.
Can I say it?
No, Jalen, you're doing number 2. Okay. Eric, can you go ahead and give us number 1 using words? Where do I go? What is going on here?
So you go down by 5, then right 2.
Good. Right 2, down 5. Thank you. All right. Now, Jalen, what do I write in my math? So let me start you off. So it's always x comma y, arrow. Okay.
X plus 2,
Mm-hmm.
comma, y minus 5.
Good. Perfect. And then my vector notation, Janelle's.
It would be 2 negative, comma negative 5.
Good job. You got it. Okay. So I think this has cleared a lot of questions. So do I have any final questions? Because the next one I'm going to have you guys try it on your own.
No.
Okay. Oh, wait. I thought there was one more, but there was not. Never mind. You got off the hook. Yeah, okay. So you will have to do it on your own in a little while, where I'm going to give you guys some practice problems. But for now, we're going to go ahead and look at this. This is a challenge problem. We're going to do a little bit of algebra. Can I have a volunteer read the problem out loud, please?
Can I read?
Go ahead, Perla.
Okay. I want you, Tyrone. Okay. A cartographer is making a city map. Line M represents Murphy Street. The cartographer translates points on line M along the vector 2, -2 to draw Nolan Street. Draw the line for Nolan Street on the coordinate plane and write its equation. What is the image of the point 0, 3 in this situation?
Awesome. Okay. So there's kind of like 3 things we're going to have to do. Number 1, we have to draw the new line. Draw the new line. Number 2, we're going to have to...
Are we doing rise over run on on the graph?
We're kind of going to have to do that, yeah.
Okay.
So
I think I
you'll
see it.
Next thing, we're going to have to write the equation. So that's going to have us, we're going to have to remember some algebra. And then the last thing is figure out the new coordinate point that they're asking about. So starting with drawing the new line, they give me the vector. So this translates, this is telling me that I'm going 2 units where?
To the left.
Oh,
Wait.
sorry, I don't mean to be pointing at the -2, I just mean to be pointing at the whole thing.
Oh.
So the whole vector tells me to do what? Okay, the +2, the first one is 2 units to the
Right?
to the right. Good. And then the -2 tells me to go 2 units where?
Down.
Good. Down. Okay. So I'm just going to pick like 3 points from the original line, any points from that line, and perform the translation. So I'll pick this one, and this one. Maybe one more, just for good measure. And each of those points, I'm going to move them according to the vector and get my new line. So 2 units to the right and 2 units down. That's my first one. 2 units to the right, 2 units down. 2 units to the right, 2 units down. 2 units to the right, and then I'm off the graph. So I'll leave it like that. So I've got 3 points, and I can draw my line. See if I can make it straight. No, hold on. That's better. Okay, so this is my new line. Each point just got moved, right? So My top point moved over here, middle one moved here, and this one moved there. That's all that happened. I want us, before we move on with the question, to notice, what do we notice about the two lines? So we have line M and line M prime. What do we notice about them?
That they're parallel.
Good. They are parallel.
Oh, I didn't expect that to be the answer.
That is correct. They are in fact parallel. And that's actually the most important thing to notice, okay? Because when you translate a line, you create another line that is parallel to the original one. And that will always be true. So let's actually write this down because it's going to be very important. So translation, hold on. Let me erase this. Okay. Translation of a line results in a parallel line. Translation of a line results in a parallel line. And the reason for that is because you're moving the line around, but are you changing the direction?
No.
Are you changing the way that it's pointing?
No.
No, exactly. So it's just going to be the same line over a little bit, and that's why they're parallel. Okay, so draw a new line. We did that. Now we need to write an equation for that line. This is where we got to go back to algebra and think about how to write an equation for a line. So what is the general form for a line, a linear equation? It's a general form of a linear equation or linear function. Type it in the chat if you know it. I know somebody out there knows it. I'm just going to sit here till somebody tells me. Okay, good. Janelle's got it. Y equals mx plus b. What does the m represent?
Slope.
Slope. What does the b represent?
Y-intercept.
Y-intercept. So we have to figure out the slope and the y-intercept of the purple line. I want to know what's the slope, and I want to know what's the y-intercept. So take 3 minutes. 3 minutes. You shouldn't even need that. 2 minutes. Find the slope, find the y-intercept. Go.
Of both lines?
Just the purple one.
Okay.
There should be one answer, Tyrone. One slope and one y-intercept. And you can send me your answer in the chat. A little less than a minute remaining. All right. Okay, so my slope is
2.
2. Good. Rise over run. You go 2 units up and 1 unit to the right. That's how I got 2. So from any 2 points, 2 units up, 1 unit to the right. My y-intercept? Someone else? What's my y-intercept?
-3.
-3. Good. So my final equation for this purple line is y equals 2x minus 3. Okay. Before I do the last part of this problem, does the black line have the same slope as the purple line or a different slope?
Same slope.
Good, same slope. So remember, parallel lines have the same slope. Same slope. Does the purple line and the black line have the same y-intercept or a different y-intercept?
Different.
Different y-intercept, very good. So same slope, different b, different y-intercept. Kind of ran out of room, but that's the rule. With parallel lines, they have the same slope, but they have a different y-intercept. All right, last part of this. It asks me, what is the image of the point 0, 3? So the original point, I'm going to call it point A, just to see where it is on the graph. That black one at 0, 3, where did that end up on the purple line?
Wait, miss, can you repeat that?
Yes, so it's asking me, what is the image of 0, 3? So it's asking me 0, 3, which I labeled it with an A. That was the pre-image. What is the image? So where does it end up on the purple line?
3, 3.
3, 3?
Yes.
Look
Oh.
back at the vector. Don't forget what the vector was. Remember, the
Oh.
vector tells you where each point goes. So based on the vector, look again.
Zero. Wait, no.
2, 1.
2, 1. You got it. How did you do that?
I did 0 plus 2,
Mm-hmm.
and then I got 2 for x, and then I did 3 minus 2, and then I got 1.
Okay, so the vector tells me to add 2 to my x value and subtract 2 from my y value. So if I started at 0, 3 and I follow the rules, I end up at 2, 1. The other way to do it is visually. You know that you're moving 2 units to the right and 2 units down. So if I start at A and I go 2 units to the right and then 2 units down, I end up at A prime. So there's always 2 ways to do it. You can either use your math or use your eyes. Kind of like slope. With slope, you can use your math or you can use your eyes. Any final questions on this problem? All right, so this one was definitely more of a challenge problem, but it does summarize everything that we've talked about so far. So now we're going to do some independent practice. So we have about I'll give you guys 15 minutes. Okay, we're gonna all right now go to student.desmos.com. Use a different tab. And put this code in when you get
Is it-
there.
Use a different tab. I have the app open.
Oh, you already have it? Nice. But make sure it's
Yeah.
student.
Miss, can I do it on my phone? Because when I do it on my computer, it gets super slow.
Unfortunately, it's not going to work well on your phone because you do have to like move things around, and that's only going to work on the computer. If it's going slow, that's okay. You don't need to.
I'm gonna get the other computer then.
Okay. So once you get there, let me share my new screen. Once you get there, you should see something like this, okay? So on the assignment, you're gonna go over on the left side where there's the rule. You're gonna write the rule for this exact transformation. So for example, so I want everyone back on Zoom. Just make sure, click back on Zoom so you can see what I'm doing.
Wait, what's the code again?
I will show it to you in a second. Click back to Zoom so you can see what I'm doing. Okay, so it's saying change the coordinate rule to move the green figure to the gray figure. So I'm going from green to gray. Make sure you read it carefully. So I'm looking and I count and I can see that, for example, point A, in order to go from A to A prime, I go 1, 2, 3, 3 units up, and then 1, 2, 3, 4, 5 units to the left. So I know that this is going to be x minus 5. So I'm going to go over here to the left side and start changing the numbers. So I'm going to change that 0 to a 5, but it has to be subtracting, right? So x minus 5. And then up, what did I say, 3 units? There you go. See how it matches up now? So you can move, and if you're not sure, you can try different numbers and see what happens. So if I put 4, I would notice that it's still too far away. Or if I accidentally put 2, just play with those numbers, put different numbers, see what you get until you get it right. Okay?
Okay.
So the code is actually at the top. You can see it at the top.
Oh.
D9E5TP.
Miss, what's the thing again? I'm sorry, the URL, I think.
Let me go back to it. Hold on.
You said toilet paper?
There you go. Yeah, you can continue without signing in. You should not need to sign in. Do I have any last questions on how to get here or what to do?
Can you say what we have to do again?
So once you're here, it's going to show you, you'll start off on the first screen. I already say I have 5 students here, so that's good. And for you, it'll look like this. And they all kind of look like that, okay? So basically, on the left side, you can edit the equation. And I believe it starts out with zeros. So you have to change those zeros into the correct numbers. And in this case, I know it's moving 5 units. Was it 5? How many? 1, 2, 3 units to the left. So I'm changing that 0 to a 3. Or maybe it was a 5. Yeah, it was 5. And then it's going to go up 3 units. So I changed that 0 to a 3. And now I matched it. So you're basically trying to get your shapes to match by changing the values of those numbers in the function. Does that make sense? Okay, cool. All right. So I see most of you guys are on. Keep working. And We'll come back at 1:45 to see how far you guys got and to go over some of the more challenging problems.